Kia ora, all back here with the 2023 TGC derived grade exams for level 2 chemistry. We're going through the bonding exam and this is question 2. This is the types of solid questions. Sorry, very loud motorbike driving past. 1, 2, thank you very much. No, 3, 4. Okay, carrying on. So, very typical questions starting with a table. So we start with silica, which is a covalent network. Please do not just write covalent. Type of particle is atoms, and actually you should know that it's Si and O atoms. Two O's for every one Si. And the force between the atoms, is covalent bonds. Sulfur dioxide with only non-metals is molecular, and its particle is SO2 molecules, and its attractive force is weak. Write it fully out. Intermolecular forces. Sodium sulfide with a metal and a non-metal part is ionic, with ions, and that is Na plus and S2 minus, and these are ionic bonds between the ions. And with just the metal, that is our metallic, and that is sodium atoms with a metallic bond. Right, so the idea with this question is that the table should allow you to have the basic information to answer the questions. So please start with a sentence which states all of the basic information from this table. So for question B1, we're talking about solid sodium being malleable and conducting electricity. So I'm starting off with sodium. I know it's metallic, composed of sodium atoms held together by metallic bonds, and that's where I'm going to start. Sodium, a metallic substance, is composed of sodium atoms held together by strong metallic bonds. And what I'm going to do is I'm going to weave in my other bits and pieces. The atoms are in a sea of delocalized electrons, and the metallic bonds are non-directional. Okay, I do actually need that one for this. So now that I've got the full structure and bonding, I've got the particles, I've got atoms, I've got the bonds, and I've got the other little bits, I need to go back and link them here. So malleable, due to the non-directional metallic bonds, where the atoms are attracted to the sea of electrons. When a force is applied, the atoms can be repositioned in the lattice without breaking the lattice, which means sodium metal can be reshaped, which is malleable. Conductivity requires moving charged particles due to the delocalized moving valence electrons charged solid sodium is able to conduct electricity. I think that's the end of that part of the question. So now we go over the page, and we are now talking about sodium sulfide's brittleness and also its conductivity. So if I go back to my table, I've got sodium sulfide, which is ionic with ions and ionic bonds. So I want to be consistent. I want to start with that. So Na2S is ionic, composed of Na plus and S2 minus ions bonded by strong ionic bonds. The ionic bonds are directional, which means when a force is applied, the ions line up and, like charges, repel, which shatters the ionic lattice, meaning Na2S is brittle. Conductivity requires moving charged particles. Possibly didn't need to say that again, but I'm going to. Sodium sulfide is composed of charged ions. However, as a solid, these ions are locked into the lattice by the strong ionic bonds and can't move. Therefore, solid Na2S cannot conduct electricity. Right, one more to go. Okay, so this one's our covalent network. So the one we haven't done for you in this exam is molecular, so do make sure you put some effort into that in your revision. So we've got silicon dioxide covalent network, atoms and covalent bonds. So I'm going to go here. Oh, no, we haven't. Look, it's two different ones this time. Okay, perfect. So SiO2 is a covalent network. Right, starting off with my particles and my forces, composed of Si and O atoms, bonded by strong covalent bonds. And since I'm comparing two different substances this time, not just the other two have been one substance with two different properties, I'm just going to start with both of the structure and bonding. So I've got SiO2 covalent network, Si and O atoms bonded by strong covalent bonds, whereas SO2 is a molecular substance composed of SO2 molecules bonded by weak intermolecular forces. And because that's long to write, I'm just going to bracket that so I can use that abbreviation now. Right, solid. So 25 degrees Celsius does not provide enough heat energy to break some of the covalent bonds and allow SiO2 to melt Therefore, SiO2 is still solid at room temperature. However, the weak intermolecular forces between SO2 molecules do not require much heat to break. So 25 degrees Celsius provides enough heat energy to break all of the WIFs. Therefore, SO2 is a gas at room temperature. And that's the end of question 2.